نقول بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. نشكر أخونا الأستاذ سعود على هذه المبادرة، ونشكر الهيئة السعودية على التنسيق وعلى التنظيم. إن شاء الله بإذن الله today we'll be talking about renewable energy and water desalination. In brief, the session will be almost like 1 hour, maybe 1 hour and a half. The slides, inshallah, will be divided into 4 sections. Before we start, I will like introduce myself. My name is Hisham Madaح. I am an associate professor in the Department of Chemical Engineering at King Abdulaziz University in Rabat branch. We have been working, alhamdulillah, in renewable energy for a while, including solar energy, including some types of organic solar cells, some things that are very friendly to the environment. We are trying to create some solar cells that are friendly to the environment instead of just the regular renewable energy resources that we have right now. So, inshallah, the presentation will be divided into 4 main parts. And if you got any questions, anything that is not clear to you, I hope you can keep the questions by the end of the session so we can go smoothly or transition from one point to another point easily and smoothly. So here, the first part, inshallah, today will be about PV. PV, it means that photovoltaic, and also we'll talk about the solar cells in general, some of the basics, some of the fundamentals that you need to get in touch when you understand, when you go into the field of renewable energy. Then we'll talk about the other part of the presentation will be passive solar cells. Passive solar cells. Solar cell is a relatively new idea. This is a technology where you try to keep the water in a tank, and then the tank will be allowing the solar energy to be absorbed, and then you try to get fresh water from your tank or from your system, or the process itself is about water desalination. Then we'll talk about how to apply some of the machine learning tools. This is the hot topic now in the industry. Machine learning, AI, artificial intelligence. This is how do you basically take it into application for your system. So this is, we'll talk about it a little bit in part 3, and then we'll talk about the new system that we have been working on. It's called solar cells. This is already have been in the research for a long time, but nobody has been taking it into the commercialization stage. So it's better to understand how the system works, so how to improve the preparation, the efficiency, also how to increase the reliability of the system. So PV solar cells, the first thing here you have to know is it all based on the physics, and the science is the same. If you look at the base of the basics of the solar cells here, or what do we mean when we talk about the junction, and when we talk about silicon solar cells? So we have to first understand how much is the efficiency now in the industry when you talk about silicon solar cells. So silicon solar cells now efficiency is around 15 to 20% max in the industry, and they try to make it even more by adding some nanoparticles, adding some let's say materials that can enhance the efficiency of the system. So the PV itself, photovoltaic. Photovoltaic means you are trying to harness the sun energy and transfer it either to thermal energy or to electrical energy directly. Some systems, they take the thermal energy and then they try to use it into different applications. Advantages of that is environmental friendly, of course, you know, and there is no any CO2 emissions coming out of the system. If we look at the properties of sunlight, this is the very best material. I'm not going to go into details in this, but this is just for information that light consists of different spectrums. You know, light is considered of waves, or basically consists of waves. Waves, it means that موجات أو طاف موجية. So we call it lambda. and then you can calculate if you have high energy or low energy from that light. Basically, most of the light that you absorb for solar cells is already in the visible spectrum. Visible spectrum, it means that low energy light with high wavelength. So you absorb almost from 300, 400 wavelength up to 700. This is called visible light. More than that, we are talking about UV light, ultraviolet. Less than that, we talk about infrared light. These are not what we are targeting, because this is most of the effect coming from the visible light by chance. So if we look at some of the equations here, photon, flux, spectral radiance, these are so different equations you can use to allow you design the system later on. So these are some of the equations here you can use. For example, if you look at this symbol, phi is, you can take the number of photons that has been absorbed and you divide it by the time and by the area of the solar cell that you have, how much area you are dealing with. So these are the ways of how to calculate how much photons or flux has been absorbed by the solar energy, by the solar cell into the silicon material that you have, the semiconductor. And then you have here some other fundamentals you have to know. There is something called AM0, for example. AM0, this is called the Earth atmosphere. How much radiation is coming to the Earth. This is the number that usually we use when we try to do the experimentation, we try to do simulation. 1.36 kilowatt per square meter this is the amount of energy coming from the sun to Earth. Is it clear to you, the sound? The sound is clear, the slide is clear. If anybody got any questions or anything is not clear, you might raise your hand, or you might just keep it in the chat. So these are the things here. Some of the material also you have to know is different wavelength actually can be, as you see here from the glass prism. If you get the sunshine ray, then you have already been able to analytically convert that into the different spectrums that we have been talking about. This is the visible lights, and from low photons to high photons. Now, if you are talking about the radiation can be different from place to place, of course, depending on what. Depending if you have clouds, if you are talking about daytime, you talk about the scattering of the energy, you talk about how much absorbed light can be done by the different pollution or different pollutants in the Earth or in the atmosphere of the Earth. So this will change the air mass, AM. So how to calculate for that? You have to know exactly, this is the AM we are using, approximately 1.36. You also need to consider the angle of the light. This is theta, how much angle of the light. This is called the zenith angle. The vertical angle of the light coming from the sun to the Earth. This also be considered if you are talking about noon time, is different than in the morning or in the afternoon. This is the theta. How do you calculate the theta from here? The angle. The absorption of the light, if you look at the different layers here, you see, from the top to bottom. Top layer you have, for example, most of the light is still not scattered. Scattered معناها يرتجع أو يعاد مرة أخرى ليش؟ into the clouds or into the earth. So most of the lights you see here will be scattered after you reach to the bottom layer down to the ground, or almost closer to the ground. So you have some light is scattered along the way, and some of the light is also absorbed by the pollutants. So these are the things you have to consider when you design any like solar cell. We have to consider the location, how much light is there, what is the angle in the location. So these are just part of the design. Let's move into another section here. We call it TN junction. TN junction, if you heard about this before, I don't know if you heard about it or not. This is, you take it in physics, you take it in some material science subject. So PN, it means a positive and negative junction. This is the place where you have the semiconductor material. We know that solar cells are made of semiconductor أو أشباه موصلات. Silicon is the most usable semiconductor in the industry because it has 8 electrons per atom. You have covalent bonds. This allows you, like, the release of one electron can escape and can go from one band to another. When you talk about valence band and conduction band later on, we'll talk about this. So usually electrons, when they take energy from the sunlight, they will go from low energy to higher energy state, and they will escape from one junction to another, or in the p-n junction we'll talk about how the electron will leave an empty space. It's called hole. When you have electron, it's called electron, E-. When you have no electron, it's called hole, and this is gonna be allowing you to have the free carriers. Free carriers معناها electrons and holes that will be allowing you to have the current generation from the system. So this is how does it look like usually. This is, for example, the electron hole pair. You see here, you have an electron and hole at the same place. The electron left the hole and he kept the place where you have no electron. This is because of what? Solar energy being absorbed, and this is only possible if you have the p-n junction. P-n junction, how does it look like? These are some other semiconductor materials you can use. From the periodic table, you can see it here. You have copper, you have aluminum, you have phosphorus, so on. But let's talk about the p-n junction itself. I don't want to go into some of the details here. This is the material itself can be provided to you from the organizers, but here I want to talk about how much energy is going to be needed for the electron to move from one low energy state to high energy state. You have to have band gap. This band gap energy should be overcome. So the electron should go from low energy to high energy. How do we do that? Look at this. This is valence band, we call it, and then it goes into conduction band. You have the valence, it means that you have low energy. You have the conduction, it means that you have high energy, and then the electron is free to go and freely allow the movement of the energy. This is the p-n junction. For any solar cell, you should have this type of configuration. You have to have a junction, or called a diode. Diode is basically, it means that one side is negative. It's like a battery. One side is positive. How do they make that? They take the silicon itself and then they inject some doping materials like boron, for example, phosphorus. You see here boron is gonna make the silicon P type because it's gonna have more holes. More holes, it means that less electrons. And the phosphorus type is gonna make the other side of the junction is gonna be negative, N type. It means it has more electrons or excess electrons from doping. Doping معناها you try to add the electron or remove electron. تدعم الوسط السيليكون سواء تضيف إلكترون أو تحذف إلكترون. So this is the way how they make it. And then you have like a battery now. You create it like a battery. You have positive side, negative side. And if you have sunlight coming into the junction, it will allow the electron from the positive side to jump to the negative side. This is the whole idea of how does the solar cell work. So you can see here, because now if you have light, the P type will allow the electrons to move from one place to another. And then the movement of the electron is translated into current generation. You are producing electricity. You are producing type of energy. This is electricity, could be thermal energy, could be electricity, whatever you call it. But basically, you try to absorb it as electricity later on. You transfer the thermal energy from the light into electricity. You convert it. So the absorption of light depends on what? The band gap. This is Eg. If you see Eg here, Eg, you have to overcome that. If you overcome this energy, band gap energy, you will allow the electron to travel and to jump from the negative side, the positive side, mostly to the negative side. So you can calculate what we already know called generation, G. Generation, it means that how much electron are going to be generated over specific photon flux over specific surface area of the cell. Everything here is in very small scale. You look at the scale here, micrometer. The cell depth is in micrometer, in micron. So this is 10 to minus 6. Alpha is what? Alpha is the absorption depth. If you look at how much actually the light is going to go into the cell itself, how deep can it go into the cell? This is, we can calculate it from the wavelength itself. There is some problem in solar cells. There has some problem. What is this problem? It's called recombination. Recombination means this electron that you have excited, when it's trying to move from one place to another, it might come back to the same place, or it might also recombine within the same layer. Not gonna go into the P side. It's gonna be maybe in the inside or the other way around. So this is there is no movement of electron. You will have recombination. You will lose the energy. You will not generate high efficiency from the system. So this is a problem you have to fix sometime. You have different types of recombination. We have different types here. You can see it. The lifetime of the electron is also important for us. The longer the lifetime, the better for the electron to stay moving into the system. So you generate more current, more electricity. This is the main junction. You see, we just said here, from the positive side to the negative side, the electron and holes will try to move freely from what? From just the rebalancing. Because here at the stage where you have no light, the region in between both, we call it depletion region. It means that you have no charges inside here between the both. And everything will be stabilized. Once you have solar light absorbed by the the silicon solar cell, you will see the movement of the electrons. You see electrons from right side to the left side and so on. And this will produce the voltage and will produce also the current that we are talking about. This is the same idea of diode. Diode is a device that is used to switch the current on and off, and the voltage will be 0 or max. If you have 0 voltage, it means that you have no current flow. If you have some voltage, it means that you have some current flowing into the system. So I hope this is clear to you, the idea. This is how you have the movements of the forward bias. If you have forward bias, it means that you are producing current. If you connect, for example, here a battery to the silicon, you will see some kind of charging. It's going to charge the battery. If you connect any lamp, for example, or any device, electrical device, it will show some electricity generated from the movements of those electrons. You see, they're going to escape the system, and then they're going to go into the device that you select here outside, and then going to come back to the N junction, the N-type junction, from N-type to P-type, and from the P-type to this device, and then so on. It moves around. So I hope this is clear so far to you. I is what here? I is how much current What is I here if you look at the equation? This is basically related to the current that you can produce from the system. You have I0. I0 when you have stabilized system, it means that dark saturation current we call it. If you have no sunlight, you can calculate I0 from experiments. You take it as a constant, then you plug it into the equation, then you can calculate your actual I from the system based on how much voltage, temperature, and K and Q. K and Q is constants here. These are related to the electron, the Boltzmann constant, and the electron charge density. So this is the first part of the seminar today. So we're gonna move to the second part, and then we can take a break after second part, because since we have 4 parts, we can take 2 parts now and 2 parts after the break. So the first part, I hope you got a brief idea about this, the solar energy and the solar cells. How do they actually work? And now let's move to the second part. It's about passive solar cell. Passive solar cell, if you look at the name, does anybody know what is passive solar cell? Have you heard this before? What is solar cell itself? Do we have the participants allowed to participate? Ustaz Saud? Ustaz Saud معنا ولا خرجت? So I don't know if you have the mic open or not. So here we have actually passive solar cell. So passive solar cell is going to be about how does the system work from just having water in the tank, and then you are trying to desalinate this water from what the technology they use here, distillation technologies. تحلية المياه, طريقة تحلية المياه, but using solar energy. So if you look at this, the problem now in the industry is that we have water scarcity. It means that the water is only 1% available in fresh water around the world. And the demand for the water is increasing, so you have to find desalination solutions. This is most of the industry now in Saudi Arabia and around the world. They are using RO, reverse osmosis technology. Reverse osmosis is a very respected technology, very advanced, but the problem is that it consumes huge amount of energy, and we have to find an alternative way to save this energy. And also it's not only consuming a lot of energy, it's also producing huge amount of carbon dioxide because you are utilizing non-renewable resource energy. So the idea here from a solar cell is you have a tank, and then you keep the water in the tank, then you try to allow this water to evaporate over the solar radiation. You have 2 types of desalination system. Either it's direct or indirect. Direct, it means that you are using the solar energy to evaporate the water directly. You take the thermal radiation and you utilize it for the evaporation of the water. Indirect, it means that you can take that electricity and use it as a thermal, use it to, for example, have thermal generation from, let's say, hot plate or any place that you have under the water tank. So this is the way of how do you actually convert it from just saline water to clean water. الشباب عندكم أسئلة? They are saying the English is not clear. What you have a problem? عادي شباب. If you are not understanding anything, we can say it in both Arabic and English. عادي. So let's continue. So the system now direct or indirect. Direct معناها مباشرة. System أو نظام يعمل بطريقة مباشرة. يحول الطاقة الشمسية إلى طاقة تعتبر هنا مكتوب إيش عندك من شمسية إلى طاقة حرارية. Direct, you are trying to heat the water. Indirect system, you are converting the energy from the solar light من طاقة شمسية إلى طاقة كهربائية وبعدين من كهربائية إلى طاقة حرارية. This is indirect system. So you are trying to convert both systems or compare both systems. The idea here is you have the same mechanism. الميكانيزم معناها عملية. How do you actually have the cycle? The cycle is gonna be the same as what you see in the natural way of condensation, evaporation of water. So if we look at the historical context of this system, it has been there for 40 years, but nobody has been able to commercialize the system into a large scale. So let's look at the differences
لو
between
سمحت دكتور
those
هشام،
systems. تفضل. ايه
نخلي المشاركات بعد إذنك تكون في آخر كذا ربع ساعة، إيش رأيك؟
ايه ما احنا اتكلمنا معاهم على اساس من بداية المحاضرة اتكلمنا على السيمينار انه كل الكيو اند اي سيشن في النهاية بعد ما نخلص المحاضرة.
ايوه تمام خلاص.
احنا بس على الان عندنا 2 sections. السكشن الان خلصناه والسكشن الثاني بعدها بنكمل بعدها 2 more sections، يعني ممكن ناخذ بريك 5 minutes نكمل بعدها 2 sections.
تمام.
واخر شيء الكيو اند اي سيشن ان شاء الله.
اوكي.
طيب let's continue. So passive solar still, it means this system is closed system. It doesn't have. So now we have 2 types of system, direct and indirect. Also you have two subtypes. 2 subtypes, it means that the direct can be passive or active, and the indirect system can be passive or active. Passive system, it means that you are having closed system with no incorporation of any heating element. ما في شيء بيسخن لك في السيستم تاني. Active system, you are adding for example heaters, boilers. تضيف شيء يساعدك انك تسخن المويه along with the solar radiation. These are the differences between both. Which one is more active or basically more efficient? Active solar still is more efficient, but it requires more maintenance, more energy consumption, more cost. It's going to be very expensive for you. So that's why I try to go with the passive solar still in the research wise. Look at the system here. This system, you can design it like this. This is a very simple, the simplest type of a system. You have this is you can design this in AutoCAD, and then from this design you can take it and then you make it in reality. This is we have done it one of the research. You have 2 compartments. This tank, the larger tank, and the smaller tank. The larger tank you're gonna use it for your feed, which is the saline water. The smallest tank or the smaller tank, you're gonna use it for your product. This is the distillate water, we call it, the clean water. So this idea is like this. You have to design it like this. It's basically glass made of plexiglass, and then you have to get your feed water. Let's say it's seawater. You put it inside. You can keep also the system insulated. تخلي السيستم معزول تماما. You have to close it completely, and then some people they add nanoparticles to increase the efficiency of the evaporation. Some people add black rubber on the bottom of the basin, like what you have done here. You can add also polystyrene material on the walls. These are all going to increase the insulation and to keep the solar radiation inside your system as much as possible. And then you have increased evaporation and condensation, and then you see the drop is going to form on your inclined cover here. This is inclined cover, transparent. زي ما انت شايف الجلاس بيكون شفاف, and then you have the water is going to be deposited, or the water is going to be taken into the distillate side or the product side. Then you can collect the clean water. This the idea is for passive solar still. It has to be done in a way where you have to large scale it. This was a very mini passive solar still. This is very small size. Some people they scale it up but nobody has scaled it up into land size, for example, huge size, industry size, mega size. We want to suggest that we have to do some simulation, some analysis. This is one of the interesting topics you can adopt, you can take it into consideration. And then you have to care about the components. These are the components. So we talk about feed side, the absorber or the basin or the bottom side, the glass cover. The frame is made of also glass. Some people, they can make it from plastic or metal, but most of the time it's preferable glass. Why? Because transparency. شفافية الglass is very important to allow the energy to enter into the system. The distillate side or the outlet for collecting the water. The key components, these are the same thing we have just mentioned now, but here you have some more components that you have to consider when you create the system. The sealant, for example, also the plate itself, the inclination, how much inclination you have, is it 20-degree angle, 10 degree, these are gonna change. These change based on the experiments, but the optimal angle is like 20. Some factors gonna influence your design. What are these factors? Solar energy, how much solar energy you have, do you have wind velocity or no, how much temperature of the atmosphere around you. The most important parameter is, we call it TG/TW. This is how much is the water temperature and how much is the glass temperature. The difference between them is gonna drive the heat transfer, and we call it heat transfer coefficient. The evaporation gonna increase if you have more differences between the water temperatures that is gonna rise from the solar radiation, and the glass temperature of the cover is gonna be less because it's not gonna absorb as the water. Then you have, these are the parameters that we already talked about, the glass cover angle again, and the flow rate is gonna be important for you. The less the flow rate, the more the efficiency you can get. But the problem is that if you decrease flow rate, you're gonna decrease the product. So you have to control it in a way you have optimal condition. The insulation of the wall, some people, they suggest it's gonna be like 5 centimeter max, because you want to keep the energy inside, but you do not also want to allow not allowing the sun energy to go into the device itself or into the cell. How much is the water depth? Some people suggest from the research, you should not allow the water to go more than 2 to 3.5 centimeter in depth inside your tank. That means you have to have a huge space of land and vast area of land to be only utilized for this system. You cannot have high depth or very large depth of the water inside the tank. Some people, they also utilize something called double slope. You see this one. This design is single slope. You can have a design with another slope in the other side. It looks like a pyramid, and then you will have double slope design. Double slope design is more efficient than single slope, but it will require you to have more maintenance and more optimization. So this is the top cover also. We just discussed this one. The latest research in the field, some people using something called nanofluids. Nanofluids mean nanoparticles. Nanoparticles like aluminum oxide, as you see here, or sometimes nanocarbons. They allow you to have more thermal conductivity, because nanocarbon, for example, in the water itself, will allow the water to absorb more of the solar radiation against the water by itself only. So this will improve the evaporation and condensation rate. And if you ask yourself, how do we treat water with nanocarbon? Are we gonna have distilled water or clean water with carbon? No, this is evaporation condensation. Once it evaporates, it will condensate into clean water. Regardless if you have carbon, aluminum, anything else, it's going to be remaining to the feed side. So these are the things you have to consider when you unit design. Some of the recent studies also used something called PCM. PCM means phase change material. The phase change material, these are the material which can change its phase from solid to liquid or liquid to solid from absorbing the heat. These are very great material for thermal storage. They can store the thermal energy, and they use it inside the still or inside the basin. And you see here how much the efficiency or the productivity can increase, can double. From 1500, for example, up to like 3700. This is almost like doubling the productivity of the system. And double basin system is also high. If you have double basin system, you have more than one basin, so you can maximize the efficiency. Some of the studies here we just collected for you and from the previous research. If you look at the different studies up to 2019, you see it's starting from 1994 up to 2019. The still output or the how much is produced from the system is relatively almost not has increased much. It was like more than 30 years ago. It was how much? 1,000 in milliliter per day per square meter of the cell. Now is around 4,000, 3,000. It's increased like 3 times, 2 times only. The research is very, very limited in this field. We have to consider mega scale projects. This is one of our previous work that we have worked on. This is the idea of the same single solar still that we have designed. You have evaporation from this side. Saline water is here, which you water with salt, and then you get the distilled water on the other side. You have to analyze some of the parameters here called the depth of the water, maximum depth of the water, depth of your still itself, and so on and so forth. So this is basically the end of this section. Next section, inshallah, we'll talk about the machine learning. You see here some of the machine learning tools can be like integrated into your analysis for understanding how do you get predictivity. It means that how do you predict the performance without doing any experiments. So this is what we're going to talk about in the next session. So let's take a break for now, like 5 minutes to pray, and then we get back inshallah to continue the 2 more sections, the remaining 2 sections. أستاذ سعود معنا؟
معك يا دكتور.
طيب let's take a break now and then we continue. ناخد بريك كده نصلي بس نرجع.
يلا تمام. نعطيك كم البريك بعد ذلك؟
إذا 10 دقائق دعم كويس عشان نلحقوا.
طيب نخلي البريك 10 دقائق يا جماعة الخير ونرجع.
خلاص 10 دقائق نرجع إن شاء الله. Maybe 7:25 is okay. تمام. يعطيك العافية سعود.
الله يعافيك.
السلام عليكم ورحمة الله. أرجو باقي شباب. We want to continue.
وعليكم السلام ورحمة الله وبركاته.
إيه أستاذ سعد خلاص موجودين؟
يلا أبدأ. موجودين الإخوان موجودين. تفضل.
طيب let's continue. So this is the third part of our presentation today, inshallah. This is the third part is going to be about machine learning. Machine learning is a process, or it's basically an idea of how do you utilize mathematical models and how you utilize regression equations or classification equations to identify a pattern or identify your, for example, relationship between input and output. In like brief way, we can say that you give just data set to the machine learning toolbox. You can use any toolbox, or you can use any pre-coded material or pre-coded applications. You give to them your data, and the data itself is going to be analyzed by the toolbox. You can either use supervised machine learning analysis or unsupervised. The details or the differences we can discuss it later on. But the idea is that if you just give the data to the toolbox, he will take it, analyze it, and he will give you some pattern between your data, whether you give it feed, or you give it distillate, you give it solar radiation. For example, you talk about solar still. You give it, for example, how much is the temperature of the atmosphere. He will analyze all the data, and then he will give you a relationship between how much you are producing water, for example, compared to your parameters or input parameters. What we are using and what we prefer to use is called supervised material or supervised machine learning analysis. It means that you just give to the programmer or to the toolbox, you give it to them specifically that you know what is your input and you know what is your output. You usually call the output dependent parameter because it depends on all the other inputs, which are the parameters that you talked about: radiation, humidity, for example, atmospheric conditions, temperature, and so on and so forth. You give it to them as an input, the input called independent parameter, because it doesn't depend on anything. It's just a number. The output is dependent parameter. So this is the case, and then he will find the relationship between your input and output, and then you can do the simulation, modeling, and then you can play around with the parameters and the data. So let's see what types of predictive models you can generate. You can generate something called classification. Classification, it means that this is important for you if you have some kind of classification analysis. You want to classify different groups. It means that you have more than one output as a group. This is called group functions. If you get more than one group data points as an output, you can use classification analysis. We do not use this much in like, let's say, renewable energy and desalination field. We use regression most of the time. Regression because you want to find an equation between the input and output. What kind of equation can you generate when you have an output dependent on a parameter like radiation? You can generate the equation, and then instead of doing the experimentation all the time and taking so much time in the experiments, you can just use directly the equation that you already generate from the predictive model. predictive model معناها المعادلة اللي تعطيك الوضع تقريبا الافتراضي للواقع. So it's going to save a lot of time and a lot of energy for you. Clustering is another way of understanding the data if it's not labeled. It's different than classification. But we'll focus on regression in this case. So how do you do the data gathering and the data analysis and optimization of the data? All of this should be done using these simple steps. First of all, you have to have original data. Then you can build the model from this data, input and output relationship. Then the model is going to be built here in step 2 or 3. Once the model is built based on different algorithms, you can select the algorithm that can have the maximum, what we call R square. R square, it means the determination ratio. Determination ratio, this is going to be, if it's 1, R square is 1, it means that you are predicting the same performance 100% accurate. If it's 0, it means that's 0 accuracy. You try to reach to 1 or 0.9, 0.8, this way. Then you do model validation or evaluation after that to create your model again in a way that is going to be more predictable. These are the different types of the classification you see here. Sometimes people use decision tree to do the groups. This is a very, very famous model. In the regression, we use linear, nonlinear. Most of the models are like in either of these groups. These are the differences. If you look at the differences here between the supervised, unsupervised, and reinforced. You see, supervised, you decide what are the inputs and outputs. Unsupervised learning, you do not tell him what is input and output. Some of the other models, like some of the systems in genetic engineering, for example, they do not know what is the input and output. They do not want to define those to the system. They use unsupervised learning analysis. You can look now at the algorithm of the model like this. You see, once you get the data, you can do the model analysis. You can build the model, then you can do the prediction, and then you can repeat the same process again if you have low efficiency or low predictability. So regression is the one that we are just focusing here. So you can see now one of the models. You look at this, we're going to skip all of these. This is just a repetition of the same knowledge that we are talking about. Supervised, for example, you see here the training set or the training data set. It means that the information that you give to the programmer or to sorry for that. The information you give to the programmer or to the toolbox is going to be in different categories. Input 1, input 2, input 3, input 4. And then you might have more than one output. Every single run, you only analyze one output at a time. One output at a time. One output with 3 inputs, one output with 4 inputs, whatever you like. But every single run, you analyze with one output at a time because you do not want to confuse the toolbox most of the time. If you do more than one output, it will be a little bit tedious process to go back and forth to fix the problem with the code. Look at the regression here, different types. Now, if we try to look at some results, later on I can share with you some of the results between experimentations and between the model validation or the model prediction. It will be somehow close to the reality or close to the exact information you found out from the experiments. Now let's move to the last part of this presentation. This is called the dye sensitized solar cell. This is DSSC. This is one of the interesting topics as well in the field of solar cells. Now we talked about solar cell as a silicon-based solar cell. This is organic-based solar cell. This is even more friendly because silicon solar cells, the problem is that when you try to get rid of the silicon, it's very harm to the environment. This one, organic solar cell, like organic plastic bags, for example, they just gonna biodegrade by itself over time. You don't need to do anything with that. It's not harmful to the environment. What kind of material we use in dye sensitized solar cell? From its name, we use dye, sabghat. So we use the dye instead of the silicon. And the dye itself is the organic material or is organic matter. The issue with the dye solar cell is that it still has low efficiency to compared to the silicon. For example, here you can achieve like 10%, 15% max. Silicon solar cell can achieve up to 25%, like 10% extra as compared to this kind of technology. But this technology has been around for a long time, not new as well, but in the research wise or in the research community. It's been around there like maybe around 60 years. So it's not a new technology, but the built up knowledge, the information that we are gaining in the field, the updates, the new technology, the advancements that we have, it's improving the efficiency to almost like 15%, as I just mentioned, and some people even can integrate the material called perovskite. This is a very famous material in the environment, to the DSSC, and then you improve the efficiency to the efficiency of the silicon solar cell almost like 25-30%, even 30%. So how does the system work? Here actually you have like the die itself working as a donor and acceptor material. We call it donor acceptor. Donor, it means that it gives electron, تعطي electron, and acceptor, it means that it's gonna take the electron from the electrolyte material and get it back to the semiconductor, and then allow the whole cycle to go around again for current generation. So you have to charge, you have to have charge transport to allow the current the generation. Look at the representation of this system. If you look at the schematic here or the chart, you have photoelectrode and counter electrode. Photoelectrode means you have anode and cathode, plus and minus again. And then you have the dye in between, and then you have electrolyte material here. This is the different material than the silicon solar cell. Silicon, you have silicon only as a semiconductor material. Here, what is the semiconductor material? We use titanium dioxide. This is also environmental friendly. And we use, because it's not toxic, and we use dye. The dye is going to be deposited on the titanium dioxide semiconductor material, and then the dye itself is going to act as the donor acceptor material for the electron. When the dye itself absorbs the solar radiation, it's going to have its homology level. Homology level means that the same as the conduction band, valence band. The same as how much energy you need to have to excite the electron from low level to higher level, so it can transfer from the dye itself into the titanium dioxide and then allow the electron generation. This is how does the cycle look like inside. If you look at the physics behind it, what is happening here. So in this type of the system, you look at, I just try to give notation here, 1, 2, 3, 4, look at the notations or the numbering. 1, it means that the electron is going to be in the dye itself. If you look at the purple color, the dye itself is going to be excited with that electron inside the dye from HOMO level to LOMO level. These are the abbreviations of the level of the energy levels. And then the dye will allow this electron to go into the anode part. This anode here, it means that you have what? You have your semiconductor. Here is the anode. Semiconductor material, titanium dioxide. We'll take that electron and we'll allow it to move through the cycle to the cathode, to the other side. Cathode could be, most of the people use platinum, use carbon cathode, anything that is very stable, so it will not oxidize over time. You do not oxidize it and then you reduce its efficiency. So let's say cathode is platinum. You collect that electron and then you have to have an electrolyte material here like iodide, triiodide material. This is very famous electrolyte, liquid electrolyte. Some people use solid electrolyte to make it even more stabilized. If you use iodide, triiodide like this, it's gonna take the electron, doing what we learned in chemistry, what you have already learned in chemistry before, something called reduction oxidation. Reduction oxidation معناها يختزل ويتأكسد. هياخد إلكترون وهيعطي إلكترون. And you have the equations here, the chemical reactions of what is happening. So this is the whole idea of the system. The system itself is very simple to understand, but the idea is you have to improve the efficiency of that system. How to improve the efficiency? You can look at what we called before, the problem from the system arises because of what? Recombination. Recombination, it means that electron is lost along the way before it even go through this cycle. It means that if you have in, let's say number 3 here, the iodide want to give the electron to the dye again. Instead of giving it to the dye, it has been lost and it has been recombined back to 4. This is going to reduce your efficiency, and this problem should be solved by having stable electrolyte. Stable electrolyte like solid, for example, instead of liquid, or liquid that is very, very, let's say, stabilized away from the dye. How do you deposit the layer? How do you make sure it's dry enough. All of these different parameters gonna play a role. So this is just brief about the different systems we talked about. So what we have talked about today is the silicon solar cell. This is the conventional system you already all know. The second system we talked about, passive solar cell. This is for water distillation. How do you allow the saline water to be converted to desalinated water or clean water using only solar radiation? The third topic was about machine learning. How can we apply some of the machine learning? We did not have the time to show you some of the results and some of the like coding or toolboxes. How can you use it? And the last topic is the integration of dye into a solar cell. This will allow you to generate decent efficiency, but also with very friendly solar cell. And it's gonna be lasting a long time as silicon cell. So this is the end of our session now. Let's take questions. أستاذ سعود موجود؟
موجود معك يا دكتور.
طيب احنا خلصنا الفور سيكشنز كلها الآن تقريبا خلصناها.
بإمكانك الحين يا طويل العمر تستقبل أسئلة، تشوف يعني.
طيب الآن الأودينس they have the access for the mic or no؟
يقدروا
access
يكتبون
على
شات في
الشات؟
الشات يا دكتور أحسن عشان تدخله.
طيب اللي عنده أسئلة يكتب في الشات من الشباب اللي موجودين. Anyone in the audience, if you have any questions, you can just type it on the chat, and we are ready to discuss it with you, inshallah. We have like 15 minutes max. Let's say we can finish by 8. So, inshallah, you get the chance to learn anything that is you have confusion with. We try to clarify it, inshallah, for you. اللي عنده سؤال يسأل يا شباب. أي سؤال. الله يعافيكم جميعا إن شاء الله. Slide 39 في أحد يقول slide 39. طب let's see it. سلايدات we can provide the slide to you. يعني نقدر نعطيكم السلايدات اللي بيسأل على السلايدات. نعطيها للأستاذ سعود والمنسقين المنظمين. نعطيكم PDF وإن شاء الله تستفيدوا منه. ونعطيكم الكوميونيكيشن إيميل تبعنا إن شاء الله for any further communication in the future. Slide 39. What is the question? في أحد بيسأل. Okay, explain it again. طب slide 39 here. This is the slide where we just showed you the simplest design for solar still. The left side, which is the largest tank, is gonna be for the feed. Feed, it means that this is the water that you want to clean or you want to treat. You take, for example, you have different types of wastewater. You can take brackish wastewater, you can take sea water, you can take river water, any water. You put it here in the larger tank, and then you keep it for a while. This system requires time. Solar still requires time because it depends all on what? Solar radiation. You keep it all the day long. But even in one day, you will get very few amount of droplets if the system doesn't have huge area in the land. It means that it's not mega scale system, it's a small system. So then in the other side, what will happen over time, you will have evaporation of the water. It will be evaporated until it reaches to the inclined cover, the glass cover here on the top. The evaporated water will start to condensate, forming the droplets, and they will reach to the distilled water side. This is the extension of the slide 39 in Likambisa. Next question. We have some people. What are the rules of emergency lighting? I'm not understanding this question. If you can clarify your question, make it clear so we can answer. If we are using material and water to generate energy from the solar system, this could be affecting the material with corrosion. if we are using materials and water to generate energy from the solar system. Yes, corrosion of course plays a role in all the systems, depending on the type of the material you are using inside. All the materials you are using inside your solar cell can be affected by the corrosion if and only if you are using iron materials. Iron materials and any iron based material هي اللي يصير فيها corrosion. أي material تانية if you are using let's say galvanized iron material. Galvanized معناها بتعالج الايرون ماتيريال بطبقة من الزنك من الخارج، تمنع عن الكروجين تماما. خلاص الكروجين ما يصير، ما في oxidation. Galvanized material. How to protect the tank from corrosion since the amount of water is necessary? Again, tank is what? Tank is glass. People who are using metal tank, they will face huge expenses from the corrosion. It's better to use glass or use plastic tank. In the passive method, what's the function of the black rubber covering the basin and why selecting rubber? The black rubber is a material that is gonna allow you to absorb more of the solar radiation because of blackened color or blackened basin. You know that the wavelength, like the wavelength of the black itself, the black color is the only color that absorbs most of the lights. This is we already know from the physics. If you use the black, it means that you can allow more of the energy being absorbed by the basin. What about the process of removal of accumulated salts? Yeah, salt accumulation, this is a very interesting part. This is a good question. This is one of the challenges they are facing in NEOM. I have some research we are working on in the NEOM region, in Tabuk. They are dealing only with salt accumulation and transferring the salt into useful products. You have to have a system here connected to the distilled water side and connected to the feed side where you can accumulate all this salt, take it to a salt regenerative device or salt processing let's say processing or optimization device for that. The salt itself can be converted to useful materials. They can take out the lithium to build batteries, for example, from that salt. It contains a lot of very useful materials. How can renewable energy sources like solar and wind be used to make process of photodesalination? This is a generalized question. You can use it both. The solar energy, what we are discussing now, all the different sections, you can integrate. This is what we are trying to do. التكامل بين جميع الأقسام. أنت الآن عندك solar still هنا اللي هو الحوض هذا اللي فيه الماء، وعندك solar cell اللي هي بالداي solar cell مثلا. You can integrate both systems. This is the way of doing it by simulation first. You have to do simulation and modeling, do it just in the computer, and then after you prove the concept, we can do it experimentally. Now you have integrated system. You are using solar radiation, you are using solar cell with a solar cell. This is what we are trying to do. إيميل التواصل أحط لكم هنا. إيميل التواصل تبع الجامعة اللي فيها السؤال. This is the email for you. What else we have here? Some other question. Are there any carbon emissions from renewable energy? No, there is no carbon emissions. Zero carbon emissions. If you talk about devices like solar cell and solar cell, these are zero carbon emissions. This is our goal. This is our goal in the research. We do not want to use any kind of carbon emission devices. So next one, how we calculate theta, which theta is going to be calculated if you go back. It's going to be calculated from the angle of the light compared to the location. This is we talked about here. You see, you always take your x-axis. This is the vertical line from the ground to the sky. This is at noon time. Compare it to the sun location at any other time. Let's say at 12 or noon time, theta is going to be what? Theta is going to be 0. At any time, theta is going to increase or decrease. Then you can take it and plug it back here in the AM equation. Put it here, so you find what is your AM, almost in approximation here you find it. From your point of view, did you think the opportunities to implement AI is gonna conduct the R&D, integrate, scale up? Yeah, AI is very important now in the industry. It will allow you to save a lot of time. We have now ChatGPT, we have what we call it also POE. These things will allow you to scale up the process just by the simulation and the modeling. AI is also the general part or the general umbrella, as we can say, because machine learning is part of the AI. So we can utilize it. People have to get trained on that, because now if you do not know how to use AI tools, it's going to be a problem in the industry. After 10 years, 15 years, it's going to be a basic skill. AI is going to be like using word processing software or like using Excel. How to guarantee distilled water not evaporate and return back to the main basin? Yeah, this is a good question, because this is depending on the inclination of the glass. الميلان حق الglass cover تبعك, the inclination of the glass cover will allow the water only to go to the feed, to the distillate side, to the product side. If you have non-inclined or the inclination is not optimized, let's say 10 degree or 5 degree, it will get back. Droplets slip down due to gravity. Yes. مظبوط, هذا في واحد جاوب عليه برضو. ممتازية by gravity. I think the lecture should have been titled Solar Energy and Desalination. Yeah, we're talking about both. Renewable energy is also again about solar energy. And sometimes wind energy can be used as well. How we calculate theta, we already described this one. في أحد عنده سؤال ثاني؟ This email is not to collect the PDF. The email is to communicate for any further clarification if you have, or any collaboration in the future. We have people in the industry we collaborate with sometimes. But for the recorded lecture, for example, and for the PDF of the slides, you can get it from the organizers. أستاذ سعود, بنرسل لك احنا السلايدات.
بعدين لك يا دكتور هشام في المهندس سعد النعماني.
تفضل. ايه
تفضل يا مهندس سعد, رئيس شعبة الهندسة الكيميائية الهيئة السعودية للمهندسين.
تفضل يا مهندس سعد.
السلام عليكم ورحمة الله وبركاته. أول شيء أشكر الدكتور هشام, يعني thank you very much. It was our honor in Saudi Council of Engineers and Chemical Engineering section to host you. Thank you for this informative presentation, and to tell you how great we are. This is the first presentation in our period that will last inshallah from 25 until 27. So we are glad to have you, Dr. Hisham, and we promise our colleagues and on all engineers, not specifically the chemical engineers, to bring inshallah best in industry, best in academia, to present similar inshallah presentations and to exchange ideas and technical information بحول. So thank you Dr. Hisham for this great opportunity, and wish you all the best وجزاك الله خير. Thank you for سعود فيصل الإخوان من السعودي Council of Engineers. That's all.
Yes, you are welcome, Engineer Saad. Thank you for the organization. Thank you for taking the initiative to implement this webinar. Inshallah, in the future, we'll hope that we have some kind of more of productive sessions, inshallah, from us, from the people in the in the academia, people in the industry. We are inshallah willing to be part of this kind of the initiative, and inshallah we can be having like fruitful sessions in the future inshallah. Thank you Engineer Saad.
حاضر. وانا اشوف تفاعل الشباب والاخوات في الشات انه يبون اكثر من شعبة الهندسة الكيميائية. ان شاء الله نوعدكم بذلك، وان شاء الله نتمنى تكون الدورة الحالية يعني دورة نشاط وحيوية، ولا نستغنى عن جميع يعني ملاحظاتكم او اقتراحاتكم لاي نشاط تحتاجونه. شكرا جزيلا.
شكرا
اذا سمحت لي سعود، انا رايح يعني بحط
شكرا
اذا سمحت لي سعود،
تفضل.
انا راح احط هنا في الشات الايميل حق الشابتر للاخوان والاخوات. اي نعم الايميل للاخوات والاخوان اللي محتاجين يتواصلون مع الشابتر for their يعني please give us all your comments any suggestions. بحول الله ان نقدر نفي بكل يعني اللي نقدر عليه بحول الله. يعني احنا مع المتعاونين ان شاء الله بحول الله مع الجميع نرتقي بالهندسه الكيميائيه والمهندسين كصوره عامه بحول الله في المملكه العربيه السعوديه. شكرا جزيلا.
شكرا لكم جميعا. اشكر الدكتور هشام مدة، واشكر المهندس سعد العماني رئيس شعبة الهندسة الكيميائية الهيئة السعودية للمهندسين. أشكر الجميع على الحضور، أشكر الجميع على التفاعل الجميل. إن شاء الله نعدكم إن شاء الله بالأفضل، إن شاء الله نعدكم أن جميع ما تتمنون يتحقق بإذن الله. من الآن بنزل لكم اللي هو الإيميل الخاص بشعبة الهندسة الكيميائية، في حال أي استفسار أو رغبة في دورة معينة أو في شهادات احترافية معينة أو أي شيء يعني، أو استشارة، إن شاء الله نحن راح نتواصل معكم.
بس إضافة بسيطة هنا.
تفضل
باشمهندس سعد وأستاذ سعود. هو الأفضل طبعا next time if we have some kind of interactive sessions, you know, if you have some interactive sessions اللي هو في مشاركة collaboration between or like participation between the audience and the organizers, or the audience and the speaker, so you have more fruitful session. This time we made it at the end of the session because we don't want to waste the time from the questions because it's already a short
دكتور إذا سمحت لي دكتور هشام والشباب والأخوان والأخوات، عادة نخلي الكيو ان اي في النهاية علشان يكون الوقت يعني مقنن بالنسبة يعني
مظبوط.
الاجتماع.
اتوقع في الدورات او الورك شوبس.
نعم في الدورات بحول الله. نعم تكون فري.
But in the webinar is almost like 1 hour and a half. There is no time. QA should be at the last.
نعم. وتم وضع اللي هو الايميل الشابتر chemical.chapter@saudi.eng.sa. This is a chemical engineering chapter مخصوص للكيميكال انجينيرنج شابتر للجميع، يعني ما هو للهيئة السعودية. طيب حيوصلني انا كالمهندس سعد الهيد حق الكيميكال انجينيرنج شابتر، ونتمنى يكون كل الكومنتس والريكومنديشنز ان شاء الله تكون يعني تصب في صالح المهندسين. شكرا جزيلا.
شكرا جزيلا لكم، يعطيكم العافية جميعا.
نشكر الجميع ويعطيكم العافية، وإلى محاضرات ودورات إن شاء الله أفضل المستقبل إن شاء الله.